So let's consider now we have if FA then GA, but we also have if FB then GB. So again, jointly these are not witnesses because there might be a third thing that falsifies the conditional and so the universal. But if FA and BA are the only two things, then jointly these two are witnesses. It's a matter of logic that if A and B are the only things, then if FA then GA and if FB then GB are both true, then also for all x if fx then gx is true. So we can think about the notion of a set of witnesses. So let's say we have this set of sentences, some x, fx, and gx, some x not fx or hx, and for all x, if not fx, then gx. And suppose we have then these sentences, fi and gi, and we'll call the first set box or square, the second set we'll call circle, and we have fi and gi, not fj or hj, not fi then gi, not fj then gj. So what we want to say is that the second set is jointly a set of witnesses for the first set. What does this mean? Well, so suppose that the only things that there are those that are named by the sentences. So there's a thing named by I, and there's a thing named by j, and that's it. Nothing else. We're not talking about anything else. And suppose that the sentences in circle are true. So then, in fact, the sentences in square would be true. If all of the quantifier-free sentences are true and there's nothing else, then the quantified sentences are also true. We can have this notion of a set of witnesses more broadly. It wasn't specific to those particular sentences. If we had some quantified sentences and some quantifier-free sentences, then if the quantifier-free sentences are true, so suppose that the quantifier-free sentences are true, and that the only things named by suppose that the only things there are the things that for which the quantifier-free sentences have names. If it follows that the quantified sentences are true, then the quantifier-free sentences are witnesses for the quantified sentences. Now, so, okay, that's fine. Why do we care about these? The reason we care about these is for sort of two connected issues. On the one hand, we can come up with a recipe to generate, if we start with quantified sentences, we have a recipe for generating their witnesses, namely the EI-UI method. That's one thing. On the other hand, as I'm going to now explain, we can very easily and straightforwardly generate models from a set of witness sentences. So let's say we have this set again, and we're going to call it circle. Well, it tells us fairly straightforwardly how to produce a model. So suppose that our universe has just two objects, a thing named by I and a thing named by j. Okay, so we know what that looks like. We have a universe of 0 and 1. And we'll say that I names 0 and j names 1. Or as a variable, i's value is 0 and j's value is 1. I and j being variables, they're not names for 0 and 1, but okay. Now, so, well, if 0 is in the extension of f and g, that means that fi and gi is true, because i's value 0 makes both conjuncts of fi and gi true, and if 0 is in the extension of g, then gi is true, because i's value is in the extension of g. So we know we want to have 0 in the extension of f, and we want to have 0 in the extension of g. Right now, we don't need to worry about the extension of h. We know that if 0 is like this, in the extension of f and g, and we're letting I refer to 0, then the first sentence of circle and the third sentence of circle are true. Okay, now, suppose now remember that j's value we're saying is 1. So if j is not in the extension of f, but is in the extension of g, that means that not fj or hj and not fg, then gj are true. So if 1 is not in the extension of h, then not fj is true, and so not fj or hj is true. And if 1 is in the extension of g, then gj is true, and so not fj, then gj are true. So we can modify the model by adding 1 to the extension of g and leaving it out of the extension of h. And now look, we have what we now have is a model in which all these sentences are true. Now we could also observe that if 1 is instead in the extension of h, and it's also in the extension of either f or g, then for similar reasons, not fj or hj, and also not fj or gj are going to be true. So we could instead have a model that looks like this. And we have one in the extension of f and one in the extension of h, and with leaving 0 alone. So what this shows us is that if we have a set of if we have a set of quantifier-free sentences, it's fairly straightforward to figure out what the model has to be. We just figure out, well, okay, which of the atomic sentences have to be true, and then put the right things in the extensions, where we just pick some values for the variables. But then the other thing is, if we have an initial set of quantified sentences and we produce a witness set for the initial set of sentences, and then we produce a model of the witness sets, we've also produced a model of the original quantified sentences. Because remember, if the witness set is true, so is the quantified. It's true in a model, then so are the quantified sentences. So if we can make the witness set true, we can make the quantified set true, and we know how to make the witness set true. So in this case, the quantified set which we started contains some x, fx, and gx, some x, not fx or hx, and for all x, not fx and gx. And we took a witness set for these quantified sentences, and we produced two models of that witness set, and in either of those two models, these quantified sentences are also true. So this gives us a method for producing models using the derivation system. How? Well, what we want to do is we're given an invalid argument, and we want to produce a model that shows that it's invalid. So how do we do that? Well, so what we want to do is to attempt an indirect derivation of the argument. So premises, indirect assumption. The derivation will fail. Because the argument is invalid, it's possible for the premises to be true and the conclusion false. That's what it means for it to be invalid. That's fine. And then we want to use the EI. We start with this indirect setup. And we use the EI-UI method to generate a set of quantifier-free sentences. So we have to be sure to instantiate all of our existential quantifiers and our universal quantifiers. And, maybe we proceed even further. We might have to do some subderivations and so on. But we eventually get to a point where we've instantiated all of our quantifier-free sentences. We've instantiated all of our quantifiers in the way that the EI-UI method says. We've instantiated each of the existential quantifiers to different variables, and we've instantiated each universal quantifier to all of the variables from EI and to all the names. And then we take those quantifier-free sentences, their witness set, and so then we just make a model for them. And once we make the model, then we've produced a model of the witness set, but then therefore, since it's a witness set, also of the original premises and the indirect assumption, and that's what we need a model to do. We need a model in which the premises are true and the conclusion is false. So we need to produce the model from the witness set in the right way. We need to have as many objects in the universe as there are both free variables and names, and then we assign each object to either a free variable or a name. And then you put the objects in the extension so that the sentences in the witness set are true. So if fi is in one of the sentences in your witness set, and you've assigned I for some reason to 3, then you'd put 3 in the extension of f, and so on. That's what the example is demonstrated. Once you've done that, then you have a model in which the original sentences are true. And that means you have a model that demonstrates the original argument's invalidity. So we can think of it like this. Here's our here's our premises and our indirect assumption. And we use the EI-UI method, and we get some sentences. This is our witness set of quantifier-free sentences if it's produced by the EI and UI method. We make a model of the quantifier-free sentences, and that is thereby a model of the original premises and indirect assumption, and that is a model that demonstrates the original argument's invalidity. So I'll do some examples of this actually using the derivation and invalidity modules in a separate video.